In this tutorial, we are going to learn about multi-threaded programming. So we will discuss about how we can actually perform multi-threaded programming in Java. So this tutorial is basically for multi-threaded programming in Java. So we will discuss some of the terms, the needed terms for the implementation of the multi-threaded programming. So we will just discuss in this part of tutorial. So this is the first part of this tutorial, and in this one we will just discuss about multi-threaded programming. In the next tutorial we are going to start our programming part, and we will program this multi-threaded programming in Java. So let's start with the formal definition of multi-threaded programming. So basically, multi-threaded programming consists of two words. So if you will break this whole term, it consists of two terms, multi and threaded. So we are going to see what exactly is a thread. So first of all, let me write down here what exactly is multi-threaded programming. So the definition of multi-threaded programming says that a multi-threaded program contains two or more parts that can run concurrently. So what does this mean? So a multi-threaded program contains two or more parts that can run concurrently, and concurrently also means simultaneously. So I will write down here simultaneously. So let's understand this whole definition. So let's suppose we have a program, and I'm going to represent it as a box. So let's suppose we have a program and it has some lines of code in it. So I will draw some lines in it. So let's suppose this program contains 6 lines of code. So what we know about this program, that if this is a single program, the execution of this program takes from the first line to the last line. So first line will get executed, and then the second line will get executed, and it moves on sequentially. So this is general flow of execution in a program. So if I want to if I want to divide this program in two parts, let's suppose the first part take 3 lines and the second part takes the remaining 3 lines. So now this program contains two parts. This is the part 1 and this is the part 2. So these are basically parts of a program. So now we know what is multi-threaded programming. It contains two or more parts, but the condition is that they can run concurrently or simultaneously. This means that these 3 lines of this part and the 3 lines of this part can run simultaneously. So what does this mean? This means that if the first line, so if I will say that this one is the first line, if the first line of this part is executing, then the first line of this program can also execute at the same time. So this is basically multitasking. You can see that two parts of the same program are running simultaneously, that means that we can actually run two tasks at the same time. So they can actually run concurrently or simultaneously. So people most oftenly they get confused the term multi-threading with multitasking. So basically multitasking is basically running two tasks at the same time. So multitasking is of two types. One is the thread based and another one is the process based. So we need to understand all the terms that I'm going to define in this tutorial, because these are actually needed to write our program. We will have to know the technical details behind the multi-threaded programming. So multitasking is of two types. One is thread based and one is process based. Process based means it contains the term process. So let's take an example from our real lives. So we know that we have mobile phones, and in mobile phones, when we go on to the recent apps, we will be able to see that we can run more than one app simultaneously. We can run more than one app or application simultaneously. So we can actually switch to any app and they are actually running simultaneously. So this is multitasking, but this is process based. This means that a process is the whole program. So process is basically a program in execution. So this means when two or more programs are running simultaneously, this is known as the process based. But if the parts of a program are running simultaneously, it is known as thread based. So these are entirely two different things. So let's see which of them is most preferable and why we are using multi-threaded programming and not a process based multitasking. The reason behind this is that when we do process based multitasking, it takes some overhead, because the communication between the processes will take a lot of resources, and we will discuss it in more details when we will discuss about processes in operating systems. So I'm not going into the details of what exactly intercommunication between the processes. So let's move on to the next important thing, that why multi-threading. So the question that comes to our mind at this point is, why do we need to implement multi-threading? What are the advantages? So the advantage of multi-threading program is to write efficient programs that make maximum use of processing power available in the system. So as we all know that the systems, which are the computer systems or any other system like mobile phones, we know that they have a good processing power nowadays. So if you will run a whole program in a single execution, it will not make use of the whole processing power. So our systems now support multiple cores. This is again another term which we do not need here, but I will still give you a knowledge of it, because it will make you understand more about multi-threaded programming. So systems contains multiple cores. You might have heard that the Intel processor is of quad core or octa core. Quad core means that it has 4 cores. Octa core means that it has 8 cores, and it basically means that it can run 4 threads at the same time. So if a system can actually perform so many threads at the same time, why not make use of this processing power? So we can actually use this processing power to make our programs efficient. And again, it really depends that whenever you're writing a program, you will have to be careful in which system you are deploying your program, because if your program does not support multi-threaded, you cannot use multi-threaded programming in that scenario. So this is just the technical details behind the multi-threaded programming. So let's discuss another important thing about threads. So now whenever I will speak this term thread, or whenever you will hear this term thread, you know that the person is actually talking about the part of a program. It's not the whole program, it's just a part of a program. So we know that there are 2 threads. One will run this part and the another one will run this part, and both can run at the same time. So let's discuss a very important topic at this point, which is the thread states. So I'm going to write here thread states, or the state of a thread. So a thread can have multiple states, and states basically means what is the current position of the thread, or what is the execution of the thread. So thread is a part of a program, so we have some we can actually specify the state of a thread. So let's discuss the basic thread states. The first one is the running state. And running state basically means that the thread, which is the part of the program, is currently running. So we say that the thread is in running state. Then there are some more states. One is the suspended state, which means that the thread has been suspended by the CPU or by some other program, so it is in a suspended state. Similarly, there is a resume state. Resume state means that the thread or the part of the program has been resumed, so it is not actually executing. So it is in a resume state, but it can come into a running state after making some calls. Alright, so there is one more state which is known as the blocked state. And blocked state means that a thread cannot actually it is blocked, and a thread can be blocked when waiting for a resource. So I'm going to write here, when a thread is waiting for a resource, and resource basically means memory. So whenever you heard this word resource, it basically means memory, because the resource for a program is memory. So when a particular thread wants a resource, when it is waiting for a resource, you can actually block it, and when you block it, it will no more be waiting for that particular resource. So now we're going to discuss another technical term, which is the thread priorities. And the reason why we are discussing these terms is because we are going to use these terms in the program. So we can actually change the state of a thread whenever we want to, because there are cases when we actually need to stop a thread, or to suspend it, or to resume it. So we will have to discuss about the states, then only we will be able to implement it in Java. Similarly, it holds true for the thread priorities. You will have to know about what is a thread priority, then only you will be able to use it. So what is a thread priority? So Java assigns thread priority, which basically determines, so a thread priority basically determines how that thread should be treated. With respect to others. For example, in our daily lives, we use the word priority. We say that we are going to give priority to our studies over gaming or something like that, which basically means that I'm saying that I am giving much priority to the studies than, or with respect to others, means that if there is some other part of the program or thread executing, I can actually assign a priority to that thread. So this will be useful in a lot of cases, because if a program contains some parts, we might need to assign the priority. So a higher priority means that that thread will be executed before any other thread. So this is known as the thread priorities. So as an absolute value, a priority is basically meaningless. So a higher priority thread does not run any faster than a lower priority thread if it is the only thread running. So this means that if there is only one single thread running, if there are not multiple threads running, so a higher priority thread is basically meaningless. So now let's discuss one more important term, which is known as context switch. And this term is used in a lot of places. Context switch is also an important term in operating systems, and it is mostly used in multitasking. Alright, so what is a context switch? So whenever we assign a priority to a thread, so a thread priority is basically used to decide when to switch from one thread to the next. So I'm going to write here when to switch from one thread to the other. From one thread to other. So the reason why we are actually assigning priorities is because we can actually use the priority which we have assigned to a thread to switch from one thread to another. What this means is, for example, there is a thread in a program and there is another thread in a program, and I say that this part of the program should, this thread, the thread which is running this part of the program, is having a high priority, which means that this thread will run first, it has higher priority, and this one has a lower priority. And remember, this so are running simultaneously, but this one has a higher priority. That means it will get more resource, or it will be assigned the memory or resource first by the CPU. So let's suppose I say that now I don't want to run this thread, I want to run this thread. So simply what I can do is I will assign this thread as a low priority and I will assign this as a higher priority. So see, we have used the priorities, the thread priorities, to actually switch from one thread to another, and this procedure is known as context switch or context switching. So when to switch from one thread to another, we can make use of the priorities, and we will implement all of this in our Java programs. So the rules, there are some rules obviously that determine when a context switch takes place. So let's define those rules. So there are rules when context switch. When context switch takes place. So basically this means that we want to know when a context switch should take place. So there should be some rules that define this switching, and we know how to switch from one context to the another by making use of priorities. Okay, so the first point, the first rule in context switching is that a thread can voluntarily relinquish control. So a thread, this is the first rule, a thread can voluntarily relinquish control. So what is the meaning of this whole line? So let me explain you this. So how can a thread voluntarily relinquish control? Control means now the the thread is having the control, and a thread can actually, voluntarily means that it can actually control when it should run. It can actually control the whole priority thing by itself. So let's see how. So this is done by explicitly sleeping or blocking on the pending IO. So how can a thread relinquish control, voluntarily relinquish control? This means how can a thread control whether it should execute or not. So it can do so, this can be done, this is done explicitly by sleeping or by blocking on pending IO. IO means input output. So let's see what the whole working behind this line, what this line means. So we have studied about the thread states here. You can see there is a suspended state, running state, resume state, blocked state. There is also this suspended state. So there is also a sleep state, and sleep state is actually it's basically a resume state, which means that a thread is sleeping, which means that it is not actually using any resource. It is waiting for some input output. It is waiting for a resource. Sorry, not for a resource, it is waiting for an input output. Input output means let's suppose I say that a part of the program, let's suppose this part is the thread, and this thread needs some input from some function, and then only it can proceed its execution. At that point it is waiting for the inputs, and when it is waiting for the inputs, it is actually holding the resource. This is a very important line. I will repeat that again. So if a thread is waiting for inputs and it waits from the inputs from the IO stream, which is the input output stream. So if a thread is waiting for the inputs, it is actually holding a resource. So at that point it should do something to do the context switch, so that it will not hold the resource anymore and other threads can also run. So what this means is that how can it do that? It can change a state from explicitly by sleeping, and we will see how we can actually change the state of a thread by sleeping it or by blocking it on pending input output. So whenever we identify that a thread now needs an input to actually do something, we will sleep it. We will assign the sleep state to it, and when it is sleep, you can see that it has control over it, it can voluntarily relinquish control. Relinquish means deny control. So it can actually say that, okay, now I'm waiting for the input output, so I am sleeping right now. So this is what this means. So a context switch will can take place when a thread is sleeping. So even if there is a high priority thread and now it needs input to do further executions, it will sleep, and when it sleeps, it has actually relinquished, denied control. It means that it will not execute. So the next one is a very simple one. A thread can be preempted by a higher priority thread. A thread can be preempted by a higher priority thread. So context switch can also take place when a lower priority thread that does not yield the processor is simply preempted, no matter what it is actually doing, and it is preempted by a higher priority thread. For example, let's say this is a higher priority thread here, and now we know that it is not doing any much work. So what we can do is we can actually create another thread, and we will assign it a much higher priority than this, a much higher priority. And this means that it has actually preempted a thread, which is this one, is actually preempted by the higher priority thread. So in that case also the context switch takes place. So these are the technical terms which we have used: context switch, thread states, thread priorities, and we have seen how the multi-threaded programming works. So another thing that we should know is this term which is known as synchronization. Again, an important term. So because multi-threading introduces an asynchronous behavior to your programs, there must be some way for you to enforce synchronicity so that whenever you need it, you can use it. So what does this mean? For example, if you want two threads means two parts of the program, to communicate or to share a complicated data structure. Let's suppose we have two threads here and they want to communicate with each other, and communication means that they want to share something with each other. Let's suppose it is some data structure like linked list or an array. So when they want to do it, such as linked list or data structure, you need some way to ensure that they do not conflict with each other. So it's a very important note. Two threads must not conflict each other. So this means that you will have to do multi-threading very carefully, because if you will create two threads and they actually conflict each other. For example, let's take an example. So let's suppose there is a thread. Let's suppose this is the thread 1, and I will mark it as a thread 2, and we know that they belong to the same program. They are just the different parts. So let's suppose this part of a thread does writing data. So let's suppose it is writing some data in this data structure. For example, I want to say I have an array in this manner, and now I want to insert. I will also assign some index positions to this array, and I say that now I want to write 5 at the first position. So when I'm writing 5 to the first position, this part of the program, So let's suppose there is a programmer who says that, okay, what I will do is I will create two parts of the program. One will write the data and the another one will read the data from this data structure. So these two threads are conflicting because they are going to happen at the same time. Reading and writing cannot happen at the same time because they will conflict each other. So let's suppose we are writing 5 to this data, and before writing it, at the same time you're reading the data. So actually there is no data to read before writing. So writing should take place first. So writing should take place first and reading should take place at the second time. They cannot happen at the same time. So this is the exact meaning of the conflict between two threads. So two threads must not depend on each other. They should not do something, so because they will have to run at the same time. This is the main reason why they should not conflict each other. So you will have to be careful in writing threads that if you are creating multiple threads, they are not conflicting each other. So this is basically the whole synchronization problem. Synchronization basically means that when you are writing the data at the same time, you cannot actually read that data. So these two processes need to be synchronized. So this is the exact meaning of synchronization. So the two threads should not conflict each other. So now we have a good knowledge of context switch, synchronization, thread states, thread priorities, and we now have a good knowledge of multi-threaded programming. So in the next part, in the second part, we are going to write our first program in which we will create a single thread, and we will see how we can do that in Java programming language. So that's all for this tutorial. Thanks for watching and supporting us.